All right. Cool. So the recording has begun, I hope. Yeah. So let's get started. In today's session, we are going to build a supply chain or an inventory orchestrator multi-agent system with ADK, Agent Development Kit, AlloyDB for database, and Vertex AI Memory Bank for long-term memory um, orchestration for your agent. So we'll build a Python Flask application consisting of the main orchestrator agent that routes the flow to multiple sub-agents and necessary tools to the specialist for the specialist agents like inventory specialist and logistics manager specialist. And then we are going to integrate it with memory, short-term session and context, and long-term Vertex AI memory bank. And then we are going to have a very simple visualization or web interface for it. I didn't put too much thought into the web interface itself. What was that? Oh, that's okay. Yeah. So we do have a simple web interface for the agent. However, don't read too much into it. It's just for interfacing with the application itself. Feel free to build your own application or use the code base to build something very specific for yourself, for your projects or for your business, or whatever it is that you're trying to build. So what are we going to do? What is exactly the tech stack or what is the flow? Again, like I said before, we're going to use AlloyDB for Postgres SQL for our database. AlloyDB is the 100% Postgres compatible Google Cloud's fully managed database that we've been using in the past season and also now. In the past season, we also did some Cloud SQL, and this season we are also going to do some BigQuery. But for today's session, we'll continue through with AlloyDB. Of course, we've already discussed the advantages. We talked about how the transactions are 4x faster as compared to your self-managed instance of your Postgres, and 100x faster for analytics queries or intelligence queries like AI and other things as compared to your self-managed Postgres. So you would have firsthand witnessed how fast AlloyDB is with embeddings in previous season itself, because we did a 50,000 row embeddings generation and vector search comparison. It's okay if you did not attend that session. Don't feel left out or don't feel like you've missed out. It's I mean, of course, the sessions are all recorded and all are available on Code Vipassana's website. You can go there on the landing page. You can go there and look for past seasons and look at the Codelabs and recording there. Each session is brand new. So if you're just attending one of Code Vipassana sessions for the first time today, don't feel alone. It's also nothing to be concerned about because this is a brand new application. It's a brand new stack. Of course, certain things might be unusual or new for you if you're not familiar with the stack, but just know that AlloyDB is a database and it's great. I mean, it's just Postgres on steroids, like I used to say, and I continue to say that because that's how I've experienced it. But it's super fast. It's very advanced in its AI capabilities, and its columnar compute nature makes it easy for your analytics. It's an edge tap database, which means you can do hybrid transactional and analytical processing, which is not many databases out there. So that's really the fun part. All right, so just know that as a database, a great database for now, if it's brand new for you. Next is the MCP Toolbox for databases. So we all know or at least have heard of MCP, which is Model Context Protocol, as we would like to call it, the USBC for all things agents, right? The Universal Type-C integrator. So basically what it does is it integrates tools or basic or other computer, other services to your actual agentic application. That's what MCP is. It's a standard protocol to connect your tools to agents. Tools from wherever and agents from wherever. But it depends on how much or how flexible or resilient your MCP server is in order to provision that level of what do you call that? What is the right word for it? Oh, I'm forgetting the word. Anyway, that level of flexibility in terms of providers and in terms of platforms. Yeah. In terms of platform agnostic nature, whatever it is that your tools, wherever it is your tools are from, your agent should be able to talk to it. Not many MCP servers are capable of doing it. It all depends on how you design it and how you provision the access and configurations for it. But MCP Toolbox for databases is a free, it's an open source tool from Google. And you can take a look at that Google Cloud's very own free open source service that's available to provision this MCP capability for your database tools to your agents. But the best part, it supports more, I think 47 or 57, I don't know the exact number. It is 17, some 7, a 2-digit number, that's greater than 40 and ends in 7, right? So that many databases it supports, and not all of these, of course, Google Cloud does not have 47 databases. It's across all platforms, all providers, and even cloud, not cloud, I mean, across not even a cloud specific database, any other like open source database or anything that's available out there, any provider for that matter. Go take a look at MCP Toolbox or databases documentation. You'll understand, you'll be able to orchestrate all of your tools across all of your databases in one control plane, in one orchestration layer, and connect them with your agentic application. So that's what MCP Toolbox is. It's not just a connector. Don't get me wrong. It's not just an integrator or orchestrator. It does much more. It provides security. It allows, and of course, the configuration, the connection part we already discussed, observability, and so many different things. Imagine being able to connect your tools from, let's say, AlloyDB, BigQuery, MongoDB on Google Cloud, or Neo4j, or for that matter, Spanner, anything around across all platforms, and making it all talk to one application with one orchestration layer. So that is what MCP Toolbox for databases is. Recently, we also launched the Java SDK for MCP Toolbox for databases, and we actually did one of our sessions and a session 2 using that Java SDK. Today, we're going to use the Python SDK, which was launched a while ago. That was the first SDK, that was the client library that was launched for MCP Toolbox for databases. The MCP Toolbox service itself is a binary that you can download, which you'll see today. You don't have to do the steps, because I have, like I said in the past, like we did in one of the sessions, I'll expose the service so that you all can access it. But just watch and understand, so that we don't spend so much time in the configuration, which is automated and simplified for you. However, I want you to, the concepts are new, and it's an L300, like a complex system. So I don't want you to spend time in every step, rather understand the initial setup steps, and I'll give you the service. You will focus on building hands-on the application part and understanding the components of the application layer itself. So that's what we're going to do today. So like I said, MCP Toolbox service is an installable binary that you will connect to it through the client libraries using different languages. Today we'll use the Python one. And you have to export, you can run it in your local, you have a visual way of creating and interacting with your tools through MCP Toolbox, but we are not going to do that today. We will deploy it as a service on Cloud Run, and we utilize that endpoint directly in our application. Why? Because having it as a service allows you, like today, all of us are going to use the same Toolbox endpoint. Imagine we are building different applications, right? You're going to use the same Toolbox endpoint for multiple tools, but we are not going to build multiple applications. We're going to build the same applications, but you get the point, right? Next is ADK, Agent Development Kit, a very popular framework, open source framework from Google. Of course, you would have all learned. We've talked about ADK quite a bit for the last 3 seasons. Here and there, we've used ADK. In this season's sessions, the second session where we used MCP Toolbox, we did use a framework, but we did not use ADK. We used LangChain for J. In yesterday's session, we used ADK. In today's session, also, we use ADK for agents, instructions, and the whole framework for your agents. And we use Vertex AI Memory Bank, which is the important part of today's session, which is providing long-term memory, allowing your agent to customize and personalize the preferences and past interactions across sessions for your user. You might be thinking, what is the big deal? Why do I need it? Because imagine going to a retail store, not physically, like on the digital media, on the digital mode. You have the app talking to the retail agent, and you're saying that, listen, I don't wear leather. I don't want anything made of leather. Show me some footwear. I want shoes that I can use for jogging, and so on and so forth. Now, 3 weeks later, you want to talk about the shoe or something, or you want other suggestions, or you didn't like it, you want to return it. And remember, you have to explain everything from the scratch once again to the agent. Is that a good experience? No. The reason is you want your agent to be personalized for your needs. Of course, you can store all the information, all the, this is not, we are in an agentic era, right? We are no longer using normal chats, using static choose option number one from this list of options. It's not like that. It's all natural language. We don't even want to type. We want to be like, I don't know, we want to talk in, if possible, in fewer words, right? As short as fewer words as we can is what we want to do, and we want the agent to inherently, implicitly understand our stand, understand our likes and dislikes, or what we want the agent to preempt in certain scenarios. Not that it's all already there, even though the technology is available, we have not fully utilized it for various reasons. One particular thing is the orchestration part, not having some of the things out of the box available, because customizing this using your own, you can use Firestore, you can use AlloyDB, you can use anything, BigQuery for that matter, to store session context each and every line. But imagine you say, hey, how are you? And imagine the agent conversation getting stored for every single hi and hello that you're typing. How much of a compute is there, but how much of space and how much of token, how much of context size are you going to take up each time? So we want to avoid all that, and we want something intelligent and out of the box. And that's what Vertex AI Memory Engine, Memory Bank is for you. It only takes the facts, which you'll see in today's session. You can say hi, hello, whatever. I need this, I need that, but it'll remember the facts. If you say, I'm living in Bangalore, India, the weather is like this, I want to know whether the delivery for this particular product will reach me in this time, because the weather is like this, anything going to be impacted in terms of delivery or something. So if you're asking a question like that, it will take the fact that you are living in Bangalore in India. And the next time you're talking, it's not going to store every single word that you're typing, right? So depends on how you configure. Again, what we used to call as word cloud in the past. Again, we are not going to configure a word cloud, but we are going to configure what and how you want your memory bank to understand, to perform, like how well you want your memory bank and how long you want your memory bank to store the conversation, the facts that it stores, and so on and so on. So many levels and so many layers of configuration. Imagine doing all of this manually, customizing on your own, having your own database. You can do that. I'm not discouraging you from doing that, but there's a way out of the box, and that's what we're going to build with today. All right, and session service, of course, it's not just the long-term memory. It is also about this short-term memory. Like you're talking, after 3 questions, you don't want your agent to ask, I'm sorry, I'm just a large language model. Tell me from the beginning, who are you? We don't like that, right? So we want to have the session, and we also have session context, and we also want to have the callback context and all those things, so that the application can perform better, and at the same time, the user can get a better experience. So that's exactly what we are going to do today. And the flow for the application that we are building is going to be like, the user is typing a query, and the memory bank is going to check inside its past information to see if there is anything relevant stored in the bank that it can use to talk to you or to serve you better. If it is there, or if it's not there, it will just pass it on and delegate it to the next one, which is the specialist that takes care, the orchestrator that takes care of which specialist to call, and then it will execute the corresponding tool to perform that operation. The tool which talks to AlloyDB through MCP Toolbox, the orchestration layer. All right, and the response is returned to you in a specific format. All that is boilerplate. You can look at the code, and then finally, based on the newer conversations that you have had just now in the recent interaction, it will store the significant interactions and save it back to the memory. So that's memory bank. That's what we're going to build. All right, all ready to go? Show of thumbs. If you have understood and are excited to get started. Perfect, let's get started. The before you begin step. Don't forget to copy the Codelab link. If you don't have it, please help with the Codelab's link in the chat. We have already set up the project. We have already enabled billing account, and we have linked the project and billing account, and we're all set to go. If you have not linked the project to a billing account, it's fairly straightforward. You know how I showed that you can see linked billing account and manage billing account. Go to manage billing account and select the billing that you want. That's about it. The Codelab that is there, not this Codelab, this Codelab also has it. If you go to before you begin, there is a green box, as you can see in my screen right now, which says how to redeem credits using this link, refer. The hyperlink actually has the list of steps. Moving on, activating Cloud Shell. Now that we already have a project and we have a billing account already up and running, let's go ahead and make sure you're all able to see the Google Cloud Console like this. You see the search bar on top in the center, and then to the right side of your search bar, you have the Gemini Cloud Assist button, and right next to it, you have Activate Cloud Shell button. Go ahead and click the Activate Cloud Shell button. This should provision a Cloud Shell machine and Cloud Shell editor for you. Sorry, Cloud Shell machine with editor and terminal for you. It will ask you to authorize, click Authorize. And once you have authorized, it will bring you to the terminal. Terminal is so you can talk to Google Cloud Services using G-Cloud commands or other Cloud Shell commands. Editor, if you click Open Editor, you will see the actual the editor where you can store, write projects, store projects, build and everything. Now, one thing you would want to know, because this has very minimal, it gives you space in memory and compute, right? The memory is very little that it allocates for you, right? So you may want to go there and delete your existing projects that you don't want anymore. If you don't know what you don't want, anything that you built across these throughout this season, you can delete it off because we don't want it right now, so that you get some space to execute today's session. So just delete everything. Take a minute there. Please delete everything, otherwise you won't be able to clone the project today. You may be thinking, this is a brand new project. Why is it still showing projects here? It's because it's linked to your project ID, sorry, your Gmail account, right? So it will, with the Cloud Shell machine that it allocates, it's linked to your billing account or it's linked to your email account, not just to the project. So it will be shown that. Take a couple of minutes here. Please go ahead and delete the previous projects. Otherwise, you wouldn't be able to clone today's project. All right. Show of thumbs, how many of you are ready? Deleted the existing projects in your terminal or in your editor and good to go. Cool. Thank you. Let's go to the Codelab now. So we are done with the first few steps. Go to, if you're in your terminal, click Open Terminal and come back to the terminal thing again. Make sure you're able to see your project ID here in the terminal prompt. If you're not able to see your project ID, it's going to be a problem. You will have to run the gcloud config set project ID command. It's there in the Codelab. In step 2 of the Codelab, point number 6, just copy the part where it says gcloud config set project. Copy that, come back here, paste it, and space, enter your project ID. And then it will set your project and you should be able to see your project ID. If it still doesn't show your project ID, you have to run gcloud auth login, which would tell me that you're not authenticated, which is highly unlikely because we just authenticated using your Gmail account when you open the terminal. But if it still causes issues, just do gcloud auth login and it'll ask you, it is self-explanatory. It'll ask you to click a link and copy choose authorize using authorize specific permissions, and then it'll ask you which email account you want to use, and then it'll ask you if you want to allow, and you click allow, and then it'll give you a code, copy that code and come back and paste it here, and that's it. You'll be done. All right. So that is one step you need to do. And if you're all done with it, the last and final step for before you begin is point number 7 in the Codelab. If you see, the word link is hyperlinked. So right click and copy link address from point number 7 in step 2 of the Codelab. Go back to the tab where you have Google Cloud Console open. Make sure you paste that in the tab search bar and hit enter. It should take you to enable APIs page, enable access to APIs page. You're doing this because you're telling Google Cloud that you're enabling these services for this specific project. It will ask you to confirm project, confirm it by clicking the next button. And then you can see all the services APIs that we are going to enable today for this project. Click enable. You don't have to enable it every time if you're using the same project. For example, if you're repeating this project, if AlloyDB API is already enabled yesterday, you don't have to enable it again. So if you're reusing the project and you did complete this step yesterday or the sessions before yesterday, you can just skip this part, but make sure it is the same project. If you're not sure, enable it anyway. There's no harm in doing that, but there is harm in forgetting to enable because it will throw error in the later stages. All right, so once you complete that, the enable button is disabled, as you can see in my screen, which is proof that your necessary APIs are all enabled. So close that and we're all set with before you begin. Next one is database setup. So this is the step that you don't have to do today. It is simplified. However, for you to do a one click and run, click that button, make sure it is opening it in the same tab as your Google Cloud Console with the same user login. So click trust repo checkbox, select it, and then say confirm. It will automatically open the Cloud Shell terminal with a tutorial on right. You just have to do sh space run.sh to run the script, and it will open a small web app in your local, which you can then use to configure your AlloyDB cluster instance and network setup, which will take care of everything behind the scenes. But since we have a lot of people in the call today using the same billing account project, because everyone's sharing our own project coupons, but still this is coming from the same free credit project. So it will be the resource for that project will be exhausted. So it will tax the system and you will not be able to complete that step. So for the sake of that, which we experienced in session 2, we also did the same thing in session 2 where I gave you the deployed endpoint from Toolbox. So that's what we're going to do today. So you don't have to do these steps today, but I'm just telling you what you'd ideally do to set your AlloyDB's cluster instance and network configuration. It's straightforward, but feel free to do this if you want to repeat this Codelab at your own time, to just go through it the Codelab way. Yeah. Next step. You don't have to do this step, so we are moving on to the next step, which is schema provisioning. Again, this is something you don't have to do. I'm just going to tell you what all went into preparing this data for you. So for that, I also need to open the AlloyDB instance so I can showcase a few things. I'll open this in a new tab. And in the search bar, I'll type AlloyDB. You don't have to do this. You can just watch. I'm just making the AlloyDB console ready so that I can show to you what the data looks like for today's session. All right, so what I did in preparation for this session is I created the AlloyDB cluster instance, network configuration, and everything that's required. I enabled the extensions, Google ML integration, so I can integrate with all the models that I have in Vertex AI. And I enabled the vector extension, so I can use PG vector natively from AlloyDB to store embeddings and to process embeddings and to perform vector search. And then I created the table shipments and products. Shipments with these fields: ID, name, category, stock level, distribution center, region, embedding, and last updated time. And the shipments table with shipment ID, product ID, status, estimated arrival, and route efficiency score. If you notice, the embedding column in the products table is used to store embeddings for the name, category, and some description of the product itself, converted into embeddings. So how do we do that? There is a data ingestion step. The first couple of steps are to create the tables, which is DDL. The next one is the DML, the data manipulation language, where we are going to ingest or insert data. And I'm running a procedure to a routine to just insert not 50,000 records. I think I'm inserting, yeah, I am inserting 50,000 records, which is interesting. All right, random records. So this particular SQL statement block right here, this procedure will insert a few, not a few, a few thousands of records into the products table. And as you can see right here, we have used the, are we using the embeddings column here? No, actually, we have updated the embeddings in a separate column. I'll show you that in a bit. So basically, we are inserting some dummy in the sense records that we want to use in our data in a table in the top block. And the next one, we are inserting records specific to certain what do you call that, industry, some products specific to certain industry like food and refreshment, personal care, etc., so on and so forth. Demo specific records so that we can remember what we want to search for when you're testing this application. Nothing biggie, no biggie. It's both the same table. It's inserted to products. This is also inserted to products. It's just that these are random records and these are demo specific records, so we can come back and search for something that we know will work. I mean, this will also work. It's just that this is random data. This is very specific data. Next is inserting into shipment data table. Shipment table. Here also we've generated some random records, creating shipments for 70% of the products that we've created. All right. And then again, we are inserting some duplicate shipments to show complex logistics, although these are all just for data complexity, not really significant for the architectural discussion we are having today. Next is granting the permission. We are granting execute to run embeddings function. We're basically granting execute embedding permission to the user Postgres, because the user that we are using here is Postgres on the AlloyDB instance that we have created for the data to interact with the data. And then we are providing the AlloyDB service account permission to talk to Vertex AI, because we are going to use the models both for embedding and for AI. Next is the generation of embedding step. Here we have written a simple embeddings generate update query. This is also update statement. This is also a DML to remember I told you about the embeddings column, which will store the embeddings for the concatenation of the fields name, category, and distribution center, so that when you're searching, it can search contextually, right? So we are storing the embeddings by calling the embeddings function and using the text embedding 005 model from Vertex AI. And this is the reason we enabled and granted permissions for embeddings and for talking to Vertex AI service. And this statement right here will generate embeddings for all the all the rows in the products table into the field embedding. That's it. The schema is provisioned. You don't have to do this step right now, because for the demo purposes, the toolbox, which is the next step, is already deployed and will be provisioned to you in the chat shortly. All right. Just know that we have set up AlloyDB and set up the data provision schema and everything that's required for this use case. The next part is toolbox. I already explained in detail just before we started the hands-on part today what MCP Toolbox for databases means and what that service is all about in this particular use case. So we are downloading the toolbox binary from by running these three lines of command from the Codelab in step number 5 inside this SCM agent toolbox folder, which we just created right now in this particular step. You're not going to do this. I'm just telling you what we did, right? And we're going to install this toolbox. And this is the most important part where I want you to pay attention is the tools.yaml. So basically, we discussed initially also in previous sessions what Toolbox does and how it interacts with the database. So basically, it's a binary which uses tools.yaml, which is the YAML file that holds the connection to your source, not hard-coded. Of course, you can use secrets, you can use environment variables, you can choose your own way to authenticate and to provision your sources. But for the sake of the demo, I've hard coded it. Um, and then in tools, we have defined a few tools. For example, search products by context. This is the query where we are using the cosine similarity vector search query. And then there is another tool which is check inventory level. These are database tools, basically set of queries. You can also write natural language queries, NL to SQL, because AlloyDB inherently supports that using the Vertex AI integration that it has, the feature called NL to SQL. And MCP Toolbox for databases also has the capacity to do NL to SQL. So do take a look at that. I have written some blogs and published those things. There's also a Codelab around it, but we are not using that for today's session. We are writing strict queries. The reason is the focus is not this. So we are using closed queries, not open-ended ones. Although I'm sure I've used open-ended queries like this. Search blah, blah, blah from products where name like so-and-so. That is one of the tools, which is check inventory levels. The next tool is tracking shipment status. So it is going to shipment table and tracking the status of the shipment for whatever it is that the user is asking. And then we have analyze supply chain risk. This is where we are using some advanced things like re-rank and filter shipments based on risk profiles. Remember, the risk analysis is based on what is going on in that particular region and stuff like that, right? So it's an intelligent query. However, we have written the whole query. We didn't leave it to, we did something intelligent. Sorry, I missed this part. Although I didn't think we'll discuss this in detail, but take a look at this. I have really put some thought into this. So this one is a vector search query again, but it is re-ranked using semantic ranker default. So it will take the meaning of the concatenation of these values, and it will do a re-ranking using this AlloyDB function, AI.rank, which is something that we need to highlight here, and that's why I'm doing this. Just take a look at this. So re-rank, AI.rank will actually rank values based on its semantic meaning and the prompt that you provide. So it's basically like human level validation, almost human level validation to say, rank this based on the product material. Of course, you can write query for it. Of course, you can rely on LLMs to do that for you, but this will be more accurate because you're re-ranking the results as well, and you're making the LLM think like you would using this particular method and giving appropriate prompts for it. So the reason why I'm not diving further deep into this tool is because our main focus is the memory bank part. But do take a look at these tools that we have defined here. These are the 4 tools. We have consolidated that into a tool set called supply chain toolset. Now, I have gone ahead and deployed this in Cloud Run. Of course, there are multiple ways to deploy it. You can deploy it in your own environment wherever you want and manage it. But Cloud Run is awesome. It's very intelligent. It has agent capabilities. There's so many things. So Cloud Run is the default choice for me. I went ahead and deployed it in Cloud Run. And if you like Cloud Run, you should do that too. For observability and other reasons that you continue to use Cloud Run for. So I have done the step completely and I have the endpoint available. I'm going to share this endpoint right now in the meeting chat. This is the part that you need to pay attention because you will need to store what I'm going to share just now in the chat. Please save this, copy this. I've pinned this endpoint. Leads you also take a copy of this so that if someone repeatedly asks where it is or what it is, you can just come back and paste it. Thank you. Now, if you use this link that I pasted in the chat and do a /API/toolset and hit enter and do a pretty print, you will see all the tools defined here that we just created in the toolbox. All right, so coming back, I've already deployed it. So we have completed all the 5 steps. This is the next part. You're getting hands-on at this point because we're going to set up the application and walk through the code. Show of thumbs on you if you got to understand everything we discussed so far and still find it interesting. Continue. Great. Thank you. Thanks for confirming. Going back to the Codelab, please go to the Codelab, go to step number 6, which is agent setup. So what we're going to do right now is the application is ready for you. You're going to clone this repository. You're going to update the environment variables. I'll tell you what to put where. And we'll walk through the code, and then we'll deploy the agent in agent engine, and we'll compile it, and then we'll deploy it in Cloud Run and test the whole thing. Ready? Great. Now copy the git clone command from step 6 of the Codelab and come back to your um, what is that? Terminal, Google Cloud Shell terminal. So this is where you should come back. So I'm also going there. Let me just open a new. Okay, let me just do it here, no problem. All right, so I'm just going to paste this git clone. You should also do this git clone and this, whatever you copied from the Codelab, and hit enter. There we go. So it is cloned and cloning complete. Next one, go back to the Codelab. And what is the next step? I'm doing a code walkthrough right away. We'll come back and do the code walkthrough in a bit. Don't rush into it right now because we have a few things to discuss. But before you move away from that, just do a CD and get into the project. scm-memory-agent. Just make sure you're inside this directory, and then you click Open Editor. So this should actually take you. You can just click the Open Editor button. I don't have it, so I'm going through the Open Folder route. You will have the Open Editor button just like this. You will toggle between Open Editor and Open Terminal like this easily. All right. So go ahead and make sure your editor is open. Like this. So you can see SCM memory agent. As you can see right here, we have our app.py. We'll do the code walkthrough in a little bit. But remember, we are using the os.env environment variable. So many environment variables that we are referencing here from app.py. So we need to go to .env and replace some of the placeholders. So I suggest that you all go to the .env file in the folder that we just cloned, in the project that we just cloned. Go to .env file and make sure you see GenAI use Vertex AI set to true. This means we are telling that we are going to use Vertex AI and not the AI Studio API key. Next one is Google Cloud location. Leave it at US Central 1. Next one, Google Cloud project. This is the place where you put in your project ID. Don't copy mine, put your project ID. How do you find your project ID? You can right-click the Google Cloud logo, or you can just click the project picker, and on the right-hand side, you have ID. Left-hand side, you have the project name. On the right-hand side, you have the project ID. So copy that and paste it here. Again, there is two placeholders for project ID. I don't know why I did that. It's just redundancy, but still paste it anyway because I think I'm referencing the same project ID by different variables. Bad practice, but don't do that. But for the sake of this demo, just repurpose it, paste it again in both the places, the project ID. The next one, same thing I've done with location and region. I have duplicated the values, US Central 1 in two different variables. Please bear with me and continue to use it twice in the .env file. And then next one is agent ID. At this moment, you don't know what your agent ID is. So leave it like that. Leave it as a placeholder. Same thing. In the reasoning engine name, you know what your project ID is. So replace the project ID placeholder along with the angle brackets and enter your project ID or paste your project ID there. However, you don't know your agent engine ID yet. So leave it like that. Don't replace the placeholder yet. But one thing you know is Toolbox server. So remove that placeholder variable and copy the one that I pasted in the meeting chat. That's it. So this is important. You don't need the slash. Do we need the slash? Let me see. I don't think it matters. Yeah, you don't need the slash. Just remove the last trailing slash in the Toolbox server. That's it. So you have your ENV ready. I know that there are agent engine ID placeholders occurring twice. which are not replaced yet, I understand, but we don't know yet what your agent engine ID is. So we're going to leave it alone for now and go to your app.py. Show of thumbs, how many of you were able to successfully clone the project and replace your environment variables? Great. Now, go back to the Codelab. Let's look at what the next steps are, code walkthrough. So you can go to app.py and search for orchestrator. I'm going to use the Codelab to just highlight a few things. So what is the orchestrator agent doing? It is using a Gemini 2.5 Flash model. It is giving the system instructions. It is the main orchestrator agent that talks to other sub-agents like inventory and logistics and the corresponding tools, which is, we'll come to the preload memory tool. The reason why I'm pausing here is because I've not talked to you about the memory tool yet. Just know that we're using a preload memory tool. So we'll just leave it at that. Next, scroll down, you see the inventory agent, which is one of the sub-agents. And in this sub-agent, we are giving system instructions as to what this agent should do. And we are giving a description, a proper description of what it is supposed to do. And then we are defining tools for inventory agent. If you look at the full code, you will understand what these tools are. So let's look at the full code anyway. Where are we? Go to app.py. Here we are. If you look at this code, you will see where we have tools. There we go. So here we have defined tools as a variable on top in line number 45. It is actually talking to the toolbox server, which is an environment variable pointing to the endpoint that I shared with you, where we have all our AlloyDB tools defined and in a tool set. And that's what we are storing in tools. We are loading the tool set and storing it in a variable called tools. And this is what we are referencing in the sub-agents, which is inventory and the other specialist agent, which is logistics. We're using the same set of tools because it knows which tools to pick. So we are just giving it the entire tool set. It will know which one to pick for what purpose. You can go through the prompt and other details later. Yeah. Now, I already told you what this toolbox server placeholder does here. Moving on, we need to set up the agent engine. So if you see in your app.py code, you will see a part where you have a block of comment right below these agents. You see in the first run, there is in line number 116, it says in the first run, create the agent engine by uncommenting just the line below. That's it, not many, just this one line. So what I'm going to do is I'm going to copy these three quote marks from the top and I'm going to paste it below that. Or just, where am I pasting it? I'm just going to paste it. What we are essentially doing here is uncommenting this part. Remove both the quotes actually. Remove the top three line quotes and the bottom three quotes. Because what we want to do is we are going to create an agent engine. Remember, we are deploying our agent engine because the agent engine deployed ID is required for registering the memory bank. So that's why this is necessary. First, we'll register this agent to an agent engine, and then we'll create the memory bank step. So remember a placeholder in the .env file that we left unassigned, that will get fixed right now. So go ahead to line number 114, where we are looking at 114, right? Yeah. Sorry, I'm just repeating the step one more time. I'm going to line number 116, sorry, 116, and I'm removing the three codes from 116 and I'm removing it from 123. Also, the top and bottom comment codes. The reason I'm doing that is I want to first create the agent engine and I want to print the resource name so that you can copy that. This is necessary for you. All right, so go ahead and just do, first let's do a pip install, right? Pip install -r requirements.txt. Copy this command because I'm going to send it to you in the chat. So you can run this as well. Make sure you're inside the SEM memory agent folder in the terminal, and then you do a pip install -r requirements.txt. Now that you've done it, it will install all the dependencies that are necessary for this agent. The next step, it should complete it and you should see the prompt clear. Oh, what did I do? There we go. So now what I'm going to do is Python app.py. I'm going to run this Python app.py Python file. The reason is this won't work. The reason is there are a lot of placeholders and we have not, we have to set up the agent ID and other things. So it won't work. However, this part will be complete. This is the instantiation part where you're creating agent engine. This is important because you will reference this agent engine further along in this application. So that is the only reason we are registering this application. So I'm running this. I'm going to paste this command again in the chat. Go ahead and do the same thing. Python app.py. Give it a minute. Because now it's creating an agent engine. It will display what we need. Make sure you open the .env file in the editor and wait until this important part shows up. I'll tell you which one that is. Close this. We don't want to open preview right now. Scroll up. I mean, don't close the terminal. Just close a pop-up that opens. Yeah, we don't need that. It won't work. What we need though is look for the part which shows you the agent engine info. As you can see in my screen, you should see something like info Vertex AI Gen AI dot agents and agent engines. You will see the whole thing. Don't copy the whole thing. Just copy from the part where it says the single quote part. After that, you don't have to copy the quotes. Just copy within the content within the quotes. Copy that. Oops, I accidentally did Control C. Just select that. It should be automatically copied for you. I'll do a right click and copy. Now come to your .env file. You already have a double quote there. Replace the whole thing. Replace the whole thing with the string that you copied from the terminal in the reasoning engine app name placeholder. The last part, which is the numeric reasoning engine number that you see in the end of that link that you copied, or the location that you, not location, what is it? The reasoning engine endpoint that you copied is your actual agent engine ID. So just copy that bit and then paste it in your agent ID placeholder. That's it. Now your .env file is complete. Once again, just to repeat, what we did is install dependencies using the command pip install -r requirements.txt. Next, we did Python app.py because we wanted to run the app.py to make sure our agent engine instance is created. Ideally, we would do it in two separate Python files so that I'm not looking like a clown commenting and uncommenting code in between. But it's okay. I just didn't want to do that. I just wanted to run this application twice with an error first time because we just wanted that first part to get completed, which is the agent engine creation. So that we got the endpoint for your reasoning engine and we replaced the whole reasoning engine as it is in the reasoning engine app name placeholder. And then we copied the last numeric bit of that agent engine endpoint into your agent engine ID placeholder. That's it. Now go back to app.py. You have to undo the uncomment part. So do a Control Z there and Control Z there. If Control Z doesn't work or Command Z doesn't work, just put just comment out use the 3 quotes in 116 and in the block quotes between 116 and 123. You need to comment them. Otherwise, in every run, it will keep creating a brand new agent engine. We don't want that. We want to create it only once. Nothing will go wrong if you keep creating agent engine. You will just be utilizing your resources unnecessarily. You will deploy this in multiple engines for no reason. So one time is enough. Comment it. block comment lines 116 to 123, and now go to line 124. After the first run, now we already have our agent engine block, agent engine created. So we have to uncomment the 124 line, comment out line number 126. That's a mistake. I forgot to put the hashtag hash there. So comment line number 126 also, and scroll down to line number 139 and remove the 3 codes, which is the block code. Basically uncomment the lines 127 through 138. That's all I'm saying. One of those lines is left unintentionally uncommented by mistake. So you have to comment out 126, line number 126, because it's just a comment text. All right, so basically what we're doing here is the first run, we created an agent engine, and in the future runs, we are going to update your already created agent engine by referencing the endpoint that we already declared in our .env file. That's pretty much it. So all the necessary changes now are complete. Let's walk through the code that we skipped in the previous step. So what did we do now? We created the agent engine and we set up the application to update the agent engine with memory bank configuration. So what we uncommented just now in step 2, if you go to the code, is the part where we created the agent engine previously in a skeleton mode. Basically, it was a vanilla agent engine. It was not configured with anything. Here we are actually configuring it with context-specific memory bank configuration, as you can see right here. The specification for that is memory bank config, and we are using the endpoint to the Vertex AI's Gemini 2.5 Flash model, which means there are so many other details that you can configure. There are so many other details that you can configure for your memory bank. Please reference the memory bank documentation for everything that you can do with memory bank, how you want to. I have gone with default time to live, which is very short. You have to extend it if you want by including those details in the configuration. I went with default configuration because I didn't want too many lines of code here, so I can show and talk about it, but there are many other configurations that you can do here for your memory bank. I have just configured the model. That's about it. You can talk about what kind of items you want to store, what is your application about. You can give so much information to your memory bank that can be configured through simple JSON attributes inside this configuration snippet, which we are skipping. We're going with default values. So it will intelligently, that is Gemini 2.5 Flash is the model that we are choosing here. And because it is in the default mode, it will let the model choose what is a fact versus what is fluff. All right, moving on now to the Codelab. Next step, context run in memory. Once again, we'll just review the code, and then the next step for you is deploying to Cloud Run. Up until that time, we just have to go through the code, 5 more minutes, and then we'll do the deployment. Meanwhile, show of thumbs, how many of you got to the point? Cool. There's not much complication in this Codelab because the toolbox endpoint was already shared with you. All we did was clone the repo, ran the application the first time by uncommenting the first set of comments, and then get your agent ID endpoint, use that in your placeholders in .env file, and then commented the first comment block and uncommented the second block code. That's all we did. All right, moving on, context run in memory. This is just a quick overview of how we are handling session here. As you can see right here, we have provisioned the session through app name and user ID, right? So we've created that for app name and user ID. You have to define the content. You have to define the scope, right? So we are scoping it out per user for an app. So if Abhi as a user is typing or having that conversation, this session for the entire app for my user account will remain saved. So Abhi for this app will have a session retention when I come back, right? So that's what I'm trying to. The scope is basically user level and app level. That's what I'm saying. All right. And then we are creating the session where it's necessary, and we are using the runnable method of the runner method of ADK framework to kickstart or to initialize the whole session creation and running your agent or triggering your orchestration agent steps. The next part, remember how I said we configured memory bank. Now for the next part, we are initializing the memory bank. So this is the part where we are defining the Vertex AI. There are two services that we can use with ADK memory: in-memory memory service and Vertex AI memory bank service. The difference is actually defined somewhere here in this green box right here. The in-memory service, there are many differences, but the main striking difference between the two is that the in-memory service stores all the conversations within the scope of the app for the user. Like whatever Abhi is chatting with this app will be stored if you're using in-memory service. Whereas if you're using memory bank service, it allows to store only the facts, the important things within a conversation that I'm having with the app. So that's a key differentiating factor that you would need to know. So I wanted to call that out. So as you can see right here, we have commented out in memory service. We are not using that. We are using the Vertex AI memory bank service in the scope of the agent project location as part of its initialization parameters. And then we are defining the agent. We are passing in the session because that is important. And we're also passing in the initialized memory bank service here along with the app name. That's it. What is exactly happening then? What is configured? As you can see right here, once the conversation is triggered, it goes back and checks if there is anything in memory that is relevant to what the user is chatting about. And then it comes back and then it responds or calls the corresponding subagent or the tool that is being used. And then while responding, it also takes the elements of the conversation that need to go into memory. New records that need to go into memory will also get stored. So that is exactly what is happening here in this agent execution piece where long-term memory is involved. That's what the code exactly does. All right. So that is the part which we do using add session to memory. The current session, if you do add session to memory and you pass in the session object, it will automatically take your session details and it will take only the facts because instead of in-memory service, we're using memory bank service, and it will add the session to memory as part of your agent execution. So that's what I said before. I just repeated this along with the code. Next, okay. I already told you before even responding to you, it goes to memory and checks to find anything relevant. So how is that happening? That's what we are doing using memories.retrieve function. It's part of the agent engines class. You get the memories retrieve function, and the retrieve parameters that you want to pass is the app, because the scope that we are dealing with is app name and username, user ID. So you go in there and retrieve everything that this user has stored in memory in the past as a list. We're just printing it here in this code snippet. You can run the code in local and to see what is getting printed. And we're using, remember this tools which I said I'll come back to later. We're using this tool in the orchestrator agent because we are calling this preload memory tool, which will tell the agent to go back and run the snippet to retrieve what is needed from the memory for this user for this particular app. So that's exactly what is being done here. Callback context, like I said, we cannot have a black box for a supply chain application enterprise level, right? So what we're going to do is you'll see that once the app is deployed is that we have a narrative engine. We are telling how did the agent come to the conclusion of calling this agent, or what is the trace. So that entire trace is printed in the agent on the right hand side in the user interface. You'll see that. So the entire callback context trace is visible. That's why we have used this. There's no other purpose that we've used this here. We're using that to actually understand the trail of your agent itself. All right, this step we've already completed. We are not going to run it locally again. Let's jump straight into deploying the app on Cloud Run. But before that, show of thumbs to confirm that you understood where we are. Vertex AI session service is not short-term retention implementation. Just to clarify, that session is different. Oh, I'm sorry. No, Anubhav is right. My bad. What I was going to say is memory bank service versus in-memory service. Yeah, Anubhav is right in saying the Vertex AI session service is for short-term memory, and the what is the other one? Memory Vertex AI memory bank service is for long-term memory. Where in-memory memory service is also for long-term memory, but that is for storing everything. Whereas Vertex AI memory bank service class will only store the package will only store what is fact as you configure. So thanks, Anubhav, for clarifying that. Um, cool. Let's move on to step number 9 of the code lab, which is let's deploy it to Cloud Run. Copy that code snippet, the gcloud run deploy command by using the copy code sample button. Go to a text editor where you can just paste it so that you can replace the placeholders that you replaced in environment variable. You have to do that again. Sorry. All right. So copy your project, replace your project placeholder with your actual project ID. Replace your app engine URL with your entire endpoint, your app engine endpoint that you placed in the variable reasoning engine app name in your .env, copy from .env and replace it here in your app engine URL placeholder, including the angle brackets. Again, the toolbox server, this should be the endpoint that I gave you. So leads, if you have that handy, please paste it. Otherwise, I can ping that again. The toolbox server endpoint. You already have it in your .environment .env file, so paste it from there. And the last one, the agent engine ID. This should be the numeric part of your agent engine URL, which you already placed in the reasoning engine app name variable. So once you have all of that ready, add one more parameter in the end, which is missing in the code lab. Not the parameter, not the environment variable, sorry, just another attribute or in the gcloud command itself, which is space hyphen memory space 2GI. The reason we want to do that is this will take up a little bit. Your service will be unavailable if you don't, or at least 1 GI. Your service will render unavailable if you don't assign this memory. So I recommend you to do that. I'll paste this part in the code lab really quickly. Give me a moment. Hyphen memory 2GI. You can do just 1 GI, that's enough. Just append this to the end of your gcloud command. Thank you, Anubhav. Thank you, Tejas. Thanks, Justin. Yeah, so I've pinned this. Append this parameter, this attribute to the end of your gcloud command. If you go to the code lab, copy the gcloud command, replace the placeholders from your .env file, and append this bit in the end with a space. I have already induced a space, but if the space is not getting copied, that's fine. Just introduce a space at the end of your gcloud command after you have pasted the agent engine ID. There should only be one space. Don't put multiple spaces. One space, and then paste what I've pasted in the in-call messages right now, which is the memory attribute. Now you should be good to go. Hit enter. Paste it and hit enter. Wait, maybe I'm using a wrong. Yeah, maybe I'm using a wrong thing. You don't worry, please carry on. I just entered the wrong ID in my gcloud parameter. I am authorizing because it's not recognizing my ID. You don't worry about it unless you have to authenticate also. Don't worry about what my screen is showing right now. Please go ahead and wait for your Cloud Run deployment to complete. Interesting. One. Oh, sorry, I'm in the wrong folder. Oh, my bad. Okay, so now my gcloud run deploy command is going on. Show of thumbs, how many of you completed the deployment? How many of you got the deployment URL endpoint successfully? Able to open the app? If your deployment is still going on, I will still have to wait because my deployment is going on. If you're stuck in not knowing what to replace the ID, just go back to reference your .env. If you followed that step correctly, you will know you have your engine ID return from when we ran the Python app.py, and then we have the reasoning engine app name. From that, we pasted it, and then we took the last part of that, the numeric value of your reasoning engine endpoint, and copied it to your agent engine ID. And all the variables that your gcloud run deploy statement expects um, are all here in your .env. So you just have to copy the values from here and paste it in the gcloud run deploy placeholders. All right. So once you copy that and then go back to the terminal and making sure that in your terminal, you're within the folder of the root folder of the current project, current working directory. Then you paste the gcloud run deploy command and hit enter because it will look for the source in that directory. And that's it. And it's going on. If you were stuck in one of the previous steps much early on today, please follow the Codelab later. You should be able to complete. It's pretty straightforward what we did. String indices must be integers, not str. If you are running it locally, probably you would have got that error. Let you complete the gcloud run deploy command. Just check what it should be showing other lines where the error has occurred. So just check that, come out of the terminal. If it's showing, that's a pretty annoying Python type error. That's str indices. Just look for where it is failing because most of you have already completed the deployment and my deployment is going on with that issue. So if your deployment has encountered an error in build phase, look at the build logs. If it is encountered an error in the deploy phase, you'll have to look at the logs explorer to see the deployment logs. And if it's successfully deployed, you click the link and it is failing, saying resource unavailable. Instead of 1 GI, increase it to 2 GI and then deploy. If everything else is working fine, try clicking one of the options that is showing in the agent. I'll just give it a couple more minutes for my deployment to complete. Still going on. It's building container now, so I'll have to wait. Yeah, if you have to enclose, oh, project ID enclosure. Interesting. Unless there's a space that's causing a problem. But how will you enclose it with the double quotes in the gcloud command? Wouldn't it error? I don't know. I was never able to pass it with double quotes in the gcloud command. So for anyone looking for, if that works for you, for one of you, you may want to try that option. Yeah, if you get information like there is a timeout, Amisha, you have to go to the deploy logs. You have to go to logs explorer and see what is wrong. Maybe your agent engine or something is wrong. This is actually a runtime error. You need to look at what is wrong. Okay, almost done for me. It is setting, it's creating revision. For those who have successfully, I just deployed it, not this one, but previously I just deployed it right before the session. The current one is still going on. And the link that I got was, oh, my current one is done. So anyway, I'm going to use this one, the supply chain app. So mine is successfully deployed. I'm going to click this link and open it in a new tab. As you can see right here, it's taking about a few minutes to load. I should have done a 2GI. Anyway, how many of you, show of thumbs, how many of you got the agent uh, deployed and running? Okay, great. Okay, mine has also come up. So as you can see, this is the global orchestrator, the main agent, the root agent. And as you start interacting, it will immediately starts looking in memory, storing in memory, fetching from memory if there is anything. And you can see on the right hand side is the callback trace that I was referring to. So right now I'm just going to ask premium ice cream stock. So basically I'm asking it to show me, this is just samples that I've pasted here. You can just type in whatever you want if you know the data. But since we didn't look at the data as much, I'm just using the placeholders there, but feel free to type whatever you want. Um, and once you get a response, you probably want to have an interaction like, I live in Bangalore, or I live in so and so city. This is my country. And this is what I'm looking. I'm looking for shipments to this particular region. Is there anything that you can tell me about logistics for this place and stuff like that? You can interact. So it will take the facts from it. You can understand that by referring to the fact that referring to what you think is a fact from your previous conversation in the upcoming conversations. You can do that. It's going just slow. I should have done a 2GI. Yeah, Rishivira, if you're getting a service unavailable, I don't know if you did the hyphen memory. If you missed that, you have to set the memory to be 1GI or 2GI. 2GI will be faster. As you can see right here, mine is returned. So it has given me the list of products, um, list of premium ice cream, the stock level for premium ice cream. I'm going to say I live in Bangalore, India. I would like to know any logistics information or delivery information that you may have with this city. It's taking time. I should have done 2GI. But anyway, so now you can reference this later. No specific for Bangalore, India at this time, which is fine. I'm just gonna say, okay, then what cities do you have information for? Okay, check for New York. Okay, there's none for New York. I'm just gonna say anything in Europe. What do we have here? Oh, we have Mumbai. I should have said Mumbai. Show me for Mumbai. The reason I'm having this conversation is to just take it away from the fact that I originally gave it. Um, okay, show me stock level for ice creams in Mumbai. So as you can see on the right hand side, um, you can look at the agent logic flow for every response. Specific. That's weird. Premium ice cream. Oh, that's the reason. Show me stop in Mumbai. Okay, there we go. So it was able to fetch the premium ice cream stocks for Mumbai Central. Now I want to find the same for the city that I live in. There we go. So this is what I wanted to demonstrate. So I said I want to find the same for the city that I live in while not referencing the city that I mentioned previously. So it has actually stored this in memory, Bangalore, India. So it says the inventory system does not appear to have a distribution center in Bangalore, India. Therefore, I cannot provide stock levels for this. So this is exactly what I wanted to demonstrate. Now you can come back and try it several hours later, close this session, reopen it entirely, and then start a whole new application. Say, where do I live? Right. So it should be able to tell you, say, there you go. It says you live in Bangalore, India. So that's exactly what I wanted to demonstrate. And that is the end of today's session. Show of thumbs, how many of you got your application working and got responses from your agent? How many of you understood the importance of memory in your agent, not just from this application, this demo app that we did, the perspective of this demo app, but overall? And how many of you are going to take it back to your applications to build with memory, your agents to be built with memory? Cool, that's a good number. Submit anything? No, there is no result submission today. The next result submission is tomorrow. So we have only 3 result submissions today. This season, we already completed 2 of those. However, if you were not able to participate in the result submissions in the past, you will get the link of where to submit the result in your email. I keep sending it every day. You would have received it today also. You'll receive it tomorrow along with this video from today. Yes, Anush, thank you for sending that result submission link in the chat. You will also have your username and password credentials in all of your emails that are sent from the system, from the event system. And then you will also receive what to submit for a specific session. As you go into this app, CV Labs, it will tell you what to submit. But today there is no result submission. However, the social media challenge, which we started a couple of days ago, that was Anubhav's idea. Thanks again, Anubhav. And we are going strong there. So I'd like for you folks to participate in that. And I'm going to share the link to that again here. You can continue to take that as a thing for today as well. There we go. I'll share the link. Where is it? Here you go. This is the form. Yeah, Sarojini. When you open the CV result submission app, it will ask you for username, password. It will be there in the email that you would have received before joining the session. If you just registered right before you joined the session, like 10 minutes before, I sent an email. But if you joined or registered 15 or 20, 10 minutes before the session start, then you would not have received the email. You'll get it along with today's recording. You can use that user credentials for submitting. The form is there for your social media challenge. If you want to participate, what you need to submit, what it is all about, it's there written in the form. Please take a look. And I hope the idea behind memory, using memories or making your agents or multi-agent systems context, not only context aware, but also uh, persisting of the users, and not just users information, but whatever the user is communicating with the chat. So that's exactly what we did today. In tomorrow's session, we'll talk about, we'll extend the same application. So don't delete anything now. Keep the application, because tomorrow we'll do it anyway from the scratch, because there will be new folks joining in. However, if you are here today, there's nothing you're going to lose by deleting this, because it's just an application that you have cloned. Tomorrow we will come back and build model armor part for it. or just delete the application. It's okay. I'll give the toolbox endpoint. So feel free to delete it. I don't want your agent engine to be, although I think it's an endpoint that's only triggered when it's invoked. So yeah, no problem. Either way, we'll start from scratch tomorrow anyway. There will be some changes in the code. So we will have to clone the repo again. So it doesn't matter. Delete it or keep it. It's up to you. All right. So that's it for today's session. Thank you very much for joining. I hope this was useful for you. Come back tomorrow. And because of the amazing amazing innovations that's happening right this moment, not just in Google, but also in open source community, open source world, we have extended this season into next week as well. We have two sessions, new sessions that are not currently announced in the Code Vipassana's current schedule. However, we are going to have two more, that is Monday and Tuesday. Monday, we'll be talking about context-aware agent system with BigQuery, and Tuesday, we're going to be building the agent skills with ADK. We're going to be looking at design patterns as well. Both are going to be very experiential. You'll be building with the speaker, and the speakers are going to be explaining. It's not just about, those are pretty new concepts, right? So it's okay. You can just come hands-free. Don't come hands-free. I mean, without any baggage of what you know and what you don't know. You can just come in and learn and build from the scratch. Bring a laptop, please. Yeah. Cool. That's pretty much it. See you all tomorrow in tomorrow's session for Model Armor with ADK. Thank you, everyone. Bye. Let's stop the recording now.